Hi, in this video we're going to be talking about how to solve the problem on the screen where you're basically given two strings and you need to find out the start indexes of possible anagrams. Basically, we're saying that we have this string right over here. We're going to take a look at the first index. We're going to say this is length 3, so I'm going to take a look at the next 3 letters. In this case, that's CBA. If I rearrange it, that becomes ABC, which matches my string. This is what we call an anagram. If we do the next thing right here, at the first index, we get BAE, which you probably know cannot be rearranged to ABC. Then we have AB, EBA, BAB, ABA, BAC, hey, look, that can rearrange to ABC. These can't. And then we end with ACD. So in this entire string, I'm going to go ahead and tell you that this section starts at the 6th index. We only get anagrams at 2 spots, when you start at the 0th index and when you start at the 6th index. So that's why we return 0 and 6. So basically, you need to find out which parts you can start the anagram in. Now, you can already see that with my explanation how we're going to be doing this. We're going to iterate through the string. We're going to see if the next 3 letters is an anagram of the string we're given. But how do we know whether or not it's an anagram? Because luckily, in this case, it's just ABC, right? So we can just take the original string and we can sort it, and it's going to be ABC. Because if we sort it, that means it's going to be in the right order. And if that means the string matches, it must be an anagram. In this case, if we sort the strings means sort the characters based on alphabetical order, that would be ABE. ABE is not equal to ABC. Now, the sorting strategy, though, doesn't work in all scenarios, because if our anagram string was BCA, sorting the second string would always get ABC, even though it does match with our anagram. So we can take this sorting strategy just a little bit further. We can say, well, it might not sort perfectly, but if I sort the anagram or the original string itself and go ahead and match those two sorted strings, that means it must be an anagram if they match. So what we're going to do is we're going to sort both strings, and then we're going to compare. And this is going to be done by iterating. Luckily, you only need to iterate through once for this, so it's going to have a pretty efficient time of O of n. So first, in order to sort a string, there is no obvious way, except for we know that we can sort arrays, not strings. So we can create this method that will take in a string, and it's going to return a string. First, we just convert it into an array. We sort the array. And then we return new string of array. What this does is just takes the array, or at least the characters in an array, and forms a string out of them. So we can first sort that anagram string, because we do not need to sort it every single time we iterate, because we'll sort the same way, and that's just going to take time if we do that. So we sort it outside, and now we can just begin with our iterating loop. So we can say for int I equals 0, I is less than s dot length. It's not just going to be s dot length, we're going to subtract p dot length, just so that we don't get out of bounds error. And that means we're going to have to set it equal to, because once we arrive to that like third to last index, see, 1, 2, 3, we do want to check this string. So that's why we're setting it equal to I++. Then what we can do is we can sort the sort s dot substring I to I plus p dot length. So this sorts the next couple of letters that are the length of our original string. So if the length of it's 3, in this case, we're going to be substringing the next 3 letters and then rearranging them. And we need to see if this sort dot equals our sorted p. Oh, we're going to set p equal to our new sort because we don't need the original p after it's sorted. Then we're going to go ahead and add it to our array. So let's go ahead and initialize our array. Array.add. We're going to add the index it starts at, and then we're just going to return array. So kind of as a recap, we developed a method on how to sort a string, and then we sort that substring of the next p.length letters, and we see whether it equals to the sorted string of the anagram. This is supposed to be arrays.